So today I understand we're going to go through a demo of an attack type that takes advantage of some gaps in the way that shortcut links are handled in Windows. Is that right?
Yeah, definitely. Trend Micro came across this thing. It's not necessarily a new exploit, and it's I hesitate to even call it an exploit, but it is just like an abuse of how Windows tries to display links and shortcuts with files. So we'll get into the details about like specifically like how it looks in Windows and like how Windows handles links specifically. But I wanted to focus in because Trend Micro did start the conversation on this. Like I said, it's not new information, but they did just kind of drop it as being like, hey, this is something we're starting to see kind of act up again, and just trying to put it in everybody's spotlight so that they can see that things are going on. So they came out with this article. This was back on March 18th. Basically, like I just said, this isn't a new attack, but hey, we're just seeing it. It's being taken advantage of by widespread APT campaigns. They're starting to abuse it more often than now. So they're just trying to raise the alarm so people are aware that it's coming back again.
And so, kind of top level, I know we're going to get into the nuts and bolts of how this works, but at a high level, when we talk about a double shortcut link, what does that mean? Like, what kind of attack is that? What's the function that's happening? And then, we'll go into like all of the detail of how it works.
Yeah, so the fun thing about Windows, so let's actually rewind a little bit before I get too far into it. But just what is an LNK file? It's the same. It's a shortcut file. It's Windows. Everybody knows what a shortcut file is in Windows. But the funny thing is that they're handled a little differently than any other file type. And most importantly, and it's specifically the thing that's being abused here, is even if you tell Windows to show the file extensions, links are special in the way that they will not show their file extension. They technically have a file extension of .lnk, but
Right.
there's absolutely no way you can actually enable that in Windows to see that. You can see it in logs, which is really great and helpful for us. But in terms of like the Windows UI, there's nothing you can do to see that, and that's the thing that attackers are taking advantage of. They're making link files, so they're making shortcut files that look like other files, so like a docx or an exe or something that might users might not be so wary of clicking on, so like a PDF. And if you make like a PDF, you name a file like file.pdf.lnk, it'll look like it's just file.pdf, even if you enable the file extension viewer in Windows. So that's the way that they're getting around that and making it seem like it's not something that's so malicious.
So even if you do have it set to show file extensions, it's going to show the extension of what that LNK file is linking to, and not the LNK itself.
Right. Yeah. LNK, there's no way to enable you seeing that in Windows. So it'll always either show .txt or .docx. They're trying to, sometimes they'll also put the extension name that they want to disguise something as in the name, which also adds another layer. So you can be like file.docx, and then that file itself is also different, like a .exe. So it confuses it confuses Windows in that way.
And in the article or in your research, do you have an idea of why this is becoming more prevalent again? If this isn't like a new attack, why it's starting to bubble up more in being seen more often?
Security kind of goes in these cycles where it's like people get super hyper aware about specific attacks, and users get hyper aware of those attacks as well. So they start to succeed less and less. And then
Mm.
as time goes on, people start to forget about those things and forget that they worked. And a lot of cybersecurity professionals can even assume that things will probably be patched. So they start to think like, oh, that's been patched, or we haven't talked about that in years. But that doesn't mean these things are patched. It doesn't mean that we still don't need to think about them. And this is one of those cases where Microsoft is just as happy to continue letting you do these things. They haven't patched anything about it. And then threat actors are coming in and abusing that again. And also, the threat actors kind of move on their own cycles as well. Some new people come in, old people go out, and then they kind of have to rediscover some of these older exploits that they might not have used in years, and they just kind of roll them into their current deployment of ransomware. They just kind of use that as a new way of getting in.
Interesting that even threat actor groups aren't immune to institutional knowledge loss.
Yeah, right.
Interesting. Well, okay, so we've got kind of the top level view. Let's take a look a little bit deeper and go into like what this looks like.
So we talked about LNK extensions and how you can't see them. One of the other funny things about LNK files is that you can see here the target field. So you'll see this properties window here. You'll see this if you right click on a file and just do properties, and then you can see that's specifically for shortcut files. Shortcut files will always have that target field. The funny thing about that target field is that that field actually can only display up to 260 characters, but it will fully accept up to 4096. So
Mm-hmm.
what Trend Micro's been seeing is threat actors have been basically taking that target field, putting a bunch of spaces so they fill in that 260 character buffer, and then they put in all their nasty commands after that buffer. So no matter what you do, Windows will not display the target to you. It'll just be a bunch of spaces. So even if you right click, even if you think an LNK is suspicious and you're curious, you're a responder, you're investigating things, you right click on it and then you look at the target, it's going to show up empty, and you're either going to move on or you're going to say, I don't really know. There's no evidence for me here to go off of. So you
Right.
move on, or you have to look elsewhere for your evidence. But there is actually like commands and stuff that's being hidden in that target box itself.
Got it.
Windows won't openly display it, but one thing that you could do if you're a responder, and this isn't really super scalable to like run an LNK parser on all of your links that you're suspicious of, but it might be helpful if you're working a ransomware incident or you just have a couple one-off links that may be suspicious to you. One thing I wanted to mention was just you can use a hex editor. You can look
Mm.
online, you can get all sorts of different hex editors. I'll share one that I use specifically that worked, but basically you load the file in the hex editor, and that hex editor will tell you what's hidden in that target field. Regardless of the character limit and everything, it doesn't really play by those same rules. It will show you everything that's in that target field, and then from there you can see like, okay, yep, there's something suspicious in that target field.
So I think now we're going to go through and actually create one of these link files. So the idea is they have a link that's shown in the target field. That's the one that'll actually inherit an icon and show the name. And then after that, padding to hide it in the field. They're also opening a second malicious application or running a string of commands or both.
Yeah, so the way it works is you're gonna have they're typically threat actors will get into an environment through email with this kind of thing. So it'll really usually start with like a zip file from an email, and inside that zip file is going to be the malicious file itself. So inside that you'll see a docx or a PDF or something along those lines, and it's not actually a docx or a PDF, it's actually a shortcut. And then that shortcut has one of those modified target fields where it's a bunch of spaces and then it has some command. So the idea is, and what the threat actors are anticipating, is the user's going to download that zip file from their email. They're gonna open the file itself to try and read it because they're like, okay, it's just a docx, it's just a PDF file. I'm gonna open this, and then upon double clicking on that, it's gonna try to run that target command. It's gonna run whatever's in there, and in our case, it's gonna be the threat actor's commands, which is gonna be our command to connect back to our Sliver C2 instance, and that's how they create that initial access. The one thing that I won't be demoing here is like a little bit of extra cover for the threat actors. A lot of times they will make it so that clicking on this fake docx or this fake PDF will actually open some kind of docx or some kind of PDF file so that alarms aren't raised for the user.
Sure.
Um, just so they can be like, well, the user's expecting a Word file to open, they're expecting a PDF file to open. They'll give them some garbage thing. It won't be anything super serious, but it's just so it doesn't raise any alarms. Because if a user tries to open a PDF or a Word file and nothing happens,
Nothing
and they
yet.
might
Yeah.
call IT, they might call security, flags might start going off. I'm not going to have that in my sample, but you might see that. Just because something opened for the user doesn't mean it's not malicious. Just means the threat actors are trying to hide their tracks.
It's almost like tailgating commands. They're expecting to open that link and see one thing happen, something else just kind of slipping through behind.
Yeah, exactly.
So here you've got a simulated attack coming through in like an HR email.
Yeah, so a little bit of my infrastructure here. I've got really simple. I've got a Sliver C2 server. It's an open source server that you can mess around with. I like this one just because, like I said, it's open source. It's available to everybody, but threat actors do use it. So there's a lot of good telemetry that I can use if I create data. It's a lot of same ways that threat actors will we'll see them on our network. And then the only other things I really have is a Python HTTP server set up on my Kali Linux machine so that it can serve the malicious files. The piece of software, the script that I use to create the malicious LNK is called LNK to Pwn. It's a GitHub, again, another open source tool. And basically this just it's pretty simple. You run it, you tell it what LNK, what shortcut you want to target, and then you just input the command that you want it to run, and then it'll basically make a copy of that shortcut with that command hidden inside that target field. The scenario that I have cooked up here, kind of like you're receiving a resume, so maybe your company has some openings, maybe you're somebody who's expecting a resume, or maybe you could just be someone in HR and maybe you get these all the time. Either way, there's a little bit of setup that you're trying to assume here. So you're a user who's got this resume, and this email is crafted specially in a little way too. So I actually have this looks like a link to OneDrive, but this is actually just a link that I made up. This link actually points directly to my Kali Linux server, the HTTP server that I have hosted on that. And all I did was I just typed in www.onedrive. I just made up a really fake URL and then just did the linking in when I made the email. So I did the URL linking in
Mhm.
Outlook. If you hover over it, you'll see that it's going to an internal resource, but not everybody hovers over stuff. They'll just click it. But yeah, the idea is that somebody's going to come in here and click it.
And in
Here.
a real attack, this would probably be behind some sort of convincing looking domain like OneDrive dash cloud storage or something to, on a quick glance, make it look as though it's a legitimate resource.
Yeah, they might have a domain they own that's in front of it. That's if they're a little bit more prepared. They might also just use their own, just a random IP address that they feel like burning.
Sure.
Yeah, they could certainly use any one of those. So my file is downloaded here. I'm just going to go click on open file. And then you see here, this is actually my malicious LNK file. It shows up as shortcut types. That might be one good indicator. That might be one good thing that you could tell users to be on lookout for. But otherwise, if we have shortcuts enabled, if we have anything enabled, it's not going to show the actual extension type. And I believe, I do have file name extensions enabled. And you can see here, there's nothing to tell me that this is not a docx other than that type. So we're going to go ahead and double click on this guy. It does give us a security warning, another thing that we can train users on. So we're going to open that. It does open the Word real quick. And then it just takes a minute for my session to come in and we'll see it pop up.
So in a real attack, this would be reaching out to a server that the attacker has deployed on the local machine, or this is reaching out to their remote and C2 command and control server for anyone who may not be familiar with the lingo. So this would be reaching out to a remote server, not running off of a local server, correct?
Correct. The only thing that this file, this LNK malicious file, doing is starting that connection. The Kali instance that I have here is a good example. Like you could host this anywhere, and malicious actors do host them anywhere. They'll compromise other infrastructure to host Sliver somewhere, buy their own infrastructure. That's typically not as common, but they'll try to hide behind lower reputation providers that maybe won't ask as many questions. But typically they're doing it behind other things that they've compromised or stolen, or maybe they've bought infrastructure but done it with a stolen credit card or stuff like that. But yeah, they'll host these sliver instances. They'll host their command and control instances publicly, and then their whole plan is to send you something that just starts that connection from the victim and then connects back to their server that they control. And you can
So
see
this is
that
entirely like living off the land. This is just using Windows standard link files, running Windows standard, I'm assuming PowerShell command strings.
yeah, totally. The compromised LNK file that I've created, all it's really doing is reaching out to my HTTP server and downloading malicious exe and then starting that in the background. So that's actually what's happening when you click on that LNK file. It's running a PowerShell command that runs and gets an exe on my server, downloads it to the victim machine, and then runs it. And then that exe is what initiates the connection back to Sliver, and that executable itself is something that Sliver generates. So you can
Okay.
tell Sliver to generate, make me an executable that connects back to you, and then I just bundle that in. I serve that up to the customer, or I serve that up to the victim in some way. They click it, and then all that facilitates that whole connection back to my server.
Yeah.
And then you can see here we've got the session initiated. Excellent picture is just it's like I said, Sliver comes up with these executables, and one of those things it does is also creates a random name. So that's the random name that generated for my executable. And we can run a few commands just to see where we're at. So we can hit use, and we can see we're loaded onto, so blue win 11-01 is the name of my workstation, my victim workstation here, and then I ran it as myself, so it's under my Jake account. But from here you can do any other Sliver command. That's a whole other presentation. Sliver is pretty versatile in what it can do. But from here, the attacker has an in on the network, they've got an in on the machine, so now they can start figuring out who they are. At this point, you'd probably start to see discovery commands, who they are, what privileges they have, what other access they might be able to exploit. Then they're going to start looking to move laterally, and they're all going to do that through Sliver and their connection. And they might find ways onto other machines, start more executables there, and get more connections out to their controlled infrastructure.
So you mentioned already that someone could use a hex editor to examine this link file if they have reason to suspect that there may be something going on and potentially see this modified file. But let's flip over now and like talk detection. If somebody isn't already knowing to go and check these files, what are going to be some of the indicators of this kind of attack? Is there anything that's going to show up in the logs or any detections that we've built that would be able to identify this?
Yeah. So speaking like I said before about the LNK stuff, the actual extension being in logs, that's the thing that you can like keep an eye out for. So just as a responder, just watching these things, like if you're just on Windows, there's really no way for you to tell. You'd have to either go into a SIEM where you send your logs, or you'd have to parse through the event viewer on Windows itself to see the logs that have those .lnk extensions. Thankfully, we also have a detection that we made based off of this, and it's triggering off of files that have those double file extensions with that end in .lnk. So we're looking for any files that are created that have .docx, .lnk, .pdf, .lnk, and it's an extensive list. We don't do everything because some shortcuts just, or some file extensions just aren't quite exposed in the same way. But we do most of the typical ones that attackers are going to be using as their bait, essentially. So yeah, we've got a detection that will watch for that, and what happens is if that file is seen as being created, then a detection will go off, and you'll be able to investigate. And then we've also got the file and all of the evidence parsed out, so you can see what's actually what the file name is, where it was saved to, and you can quickly make a decision whether or not if it's something malicious or if it's something expected, and you can respond inside the finding itself.
And so I imagine that there may be some cases where a valid use of a link file may have one of those extensions. What did we have to do to sort of tune that to filter out some of those false positives? Or is there anything that folks should be aware of that they can be doing to reduce the number of false positives they might see if they're trying to use that method?
I'll answer the second question first because it's a little bit easier. This is not something that's super common. People, I mean, this will trigger off of people making shortcuts in certain ways. There should be specific users that do things certain ways. You might just have to talk with them or change the way that they're like making links. That might not be super reasonable, but at least you can get an idea for who's typically triggering this stuff and who does this as like a common basis and who doesn't. But in my testing, I found that a lot of users, they're not generally making shortcuts the same way that we're looking for them. And that leads me into the answering your other question. We did a lot of tuning to this one, so it's not just straight up looking for extension and then .lnk. We did a lot of tuning to it so that we're not just detecting on all of those. And the best example, I think, in my testing, I found Autodesk does this a lot, where it's got these shortcut files and then .lnk. So there are a couple pieces of software. Autodesk is not the only one. I think Microsoft as well, when with the recent files in
Mhm.
Explorer, it triggers it a lot as well because those recent files are basically links. So we did a lot of work to tune out the Microsoft noise and all of this other legitimate software noise. So it does restrict it quite a bit, but yeah, there is still a little bit of like could be a user thing. That is why we decided to keep it as a suspect P3 priority 3 because it is something that a user could trigger, but it also could be a good early warning sign to something suspicious going on.
So somebody has this pop up in their findings. What does response, investigation, remediation from here look like?
Typically, this is going to be an initial access trigger. So you're going to be looking for things like in my example, I had PowerShell run to download the file. So you're going to be on lookout for PowerShell running weird commands, PowerShell running encoded commands, PowerShell downloading things from the internet, all detections that we also have or all activity that we also have detections for. Um, but yeah, you're going to be trying to look for the actual connection where something reaches out. You're looking for some kind of subsequent activity because this is usually used just for the initial access. So you're going to be looking for it reaching out to other things, weird processes running on your victim endpoint. And then yeah, if you can get access to the victim endpoint, you could pull that LNK file and run the hex editor and do some investigation that way just to see, because if you are able to pull that LNK into a hex editor and see what commands being run, that can guide your response. Because if you can see what commands being run, you can start to make different jumps from there and try to find other things on your network or on that victim itself.
So if I'm understanding this correct, I want to see if I can kind of sum it up for folks. So this is a resurging method that Trend Micro is reporting on, that a Windows link file is only going to show a short amount of the actual potential context space. So a legitimate link gets padding, and then a malicious command to download and install this basically broadcaster to reach out to the C2 server. Um, you can potentially find that by looking for those double linked link files in logs with kind of some of that uncommon padding and double extension naming. Um, and then I know you mentioned you can do some email security measures, making sure you have some good detections in place, and then user training, right?
The padding, the target field padding is definitely the most important thing. I think that's what has started to trigger Trend Micro to talk about this more, is not the file extension thing as much as it is seeing that in conjunction with this new discovery that that target field is vulnerable in a certain way.
Thanks for walking us through it and showing. I'm sure this is going to be interesting for folks. Anything else that you want to make sure that folks that are curious about this are aware of, or if they want to know more about these kinds of attacks, where they can go to find more information?
Yeah, the Trend Micro article is really good start. You can also just kind of search for similar terms like the Windows shortcut exploit or LNK. Like this, like I said, this is not something that's new. So there's a lot of really good information out on the internet about these kind of attacks already and like what they look like in the logs and all sorts of stuff. And I'll share some of my resources that I found along the way as well, so we can share those along with this video.
Well, thank you. I can't wait until we get to go through another demo together. And for folks that are watching, let us know what you thought. If there's another demonstration you'd like to see in the future, and we'll see you again soon.